Welcome to Team Xanda's Project Hack 17 presentation for Challenge 10, Project Chatter Bot. Put together with Python, Go and React by Rao, Jason, Aaron, Oscar and Sam, with myself Alex lending my voice to this. A quick thanks to our host Projecting Success and our challenge sponsor Dale from the brilliant Project Chatter podcasts. Okay, let's get cracking. The Project Chatter podcast started in 2019 and now boasts over 200 hours of interviews with global experts centered around project management. With an ever-growing catalogue of 146 episodes rich in discussion and debate, Project Chatter are looking to offer a tailored content instant access bot for content search, or getting to their nuggets as they call it. They'd also like to consider viewer sentiment analysis to establish the community mood on various topics, as well as widening access beyond the podcast's English audio-only format. Our product is therefore focused on two main personas: Project Chatter content creators and their content consumers. First and foremost, we have a data ingestion and processing pipeline covering 5 main steps: speaker diarization, audio segmentation, automatic speech recognition and transcription, sentiment analysis, and keyword identification. And as we ran out of time, some limited translation, which we'll come on to later. We've taken a sample of 10 episodes in raw audio format for this challenge, as processing all 146 episodes over the challenge just wasn't feasible. Throwing them into the engine, we start with speaker diarization in order to identify partitioning points of the raw audio stream into homogeneous segments according to the speaker identity. By answering the question of who spoke when, this step's aim is to enhance the readability of an automated speech transcription by structuring the audio stream into speaker turns, limiting transcription processing to a single accent and timbre of speech. We're using the PioNote library to efficiently manage this step, as it's well suited for the conversational style of the podcast, including overlap speech detection and handling. The second stage then uses PyDub to handle the splitting of the raw audio file into each speaker turn based on diarization output ready for transcription. With Dale and Val being South African and Australian respectively, and guests from all corners of the world, our engine requires an automatic speech recognition and transcription engine capable of handling different accents. This third step utilizes Whisper Neural Net, which, trained on almost 750,000 hours of multilingual audio data, offers improved robustness to accents, punctuation, and technical language recognition. Next, we move into sentiment analysis. We've used Vader sentiment for this step, so cue unnecessary Star Wars iconography. Vader is used to analyze the sentiment on each speaker turn, as well as the sentiment for the search terms being processed by the bot. For example, why is scope creep bad can then search for audio segments containing the key phrase scope creep where the sentiment of the audio is negative. Conversely, when can scope creep be a good thing can prioritize segments where scope creep is used positively. This provides an extra layer of tailoring not possible with the more traditional key phrase lookup. Our penultimate process is keyword identification. We're using Spacey for this step. We're using the keywords in conjunction with the inbuilt NLP processing of the persistence layer to support more accurate relevancy for content consumer searches and analytics. All the podcast metadata is then saved into MySQL 8 to utilize its natural language processing for searches. And whilst we had wanted to integrate translation into the engine, we ran out of time. But we did manage to squeeze translating one podcast transcription into Portuguese, only because Oscar could validate the translation, and then use PyTTS3 to automatically create a Portuguese spoken version of the podcast. With the data now ready to exploit, we created both a Chatterbot audio search engine app and an analytics portal providing insights to help produce new podcasts the project management community would be even more interested in. We take both the sentiment and search term for each search, saving them for analytics, and then use NLP searching and relevancy scoring to deliver the most relevant episodes with a related audio segment ready to play the moment the podcast starts. Our podcast player provides the transcribed content for subtitles with speaker distinction to increase accessibility for consumers who have hearing loss, and for the episode we translated, provides simple access to change language for both the audio and subtitles. The natural progression would be to automatically generate localized subtitles and audio versions and run additional algorithms to identify each speaker by names identified in the content itself. Single audio file in, multiple localized versions out, and of course each version would be available to the search bot for localized search results. From a data analytics and insights perspective, the search analytics allows podcast creators to track search keywords and location searches are coming from. In terms of consumption analytics, data is broken down to derive insights on an individual podcast level. We're able to track plays over time to judge the mood on demand for information over topics within podcasts, both in terms of the episode as a whole, as well as individual audio segment levels. We're able to track speaker popularity in terms of the number of plays of audience segments under which they have control of the mic. presenting this side by side with a percentage of time within each episode that a speaker has been talking, helping to identify if the length of time someone is talking affects consumer engagement within those sections. Whilst limited at present, the platform allows for a wide range of data capture points to further augment the value of data insights. Coming back to the hack and to answer the judge's questions regarding inaccuracies in the transcription, we can utilise the Whisper large model for improved recognition, albeit with a processing time trade-off. Services such as the Hugging Face Hub use popular Python libraries to allow for custom datasets to be created for custom training data and transformers to train the Whisper model itself. Finally, as we have the transcription stored directly in the database, it would be a simple process to provide the admin portal access for content creators to manually override transcriptions. Should a community of language editors be available to edit localized content, the localized audio could then be regenerated at a single click. To answer question 2, once the chunked audio files have been processed for transcription, they are no longer required and are discarded. The engine can always regenerate them when required. An off-the-shelf object storage solution supported by a CDN would be an appropriate storage solution for a low-cost, highly available service with fast delivery and reduced bandwidth in serving the content to the content consumer. To enrich the data further for question 3, we'd look to reference a PPM glossary to display and explain technical terms and acronyms as they appear in each audio segment. We'd also look to track and report on user disengagement, remembering where a consumer left off and returning them to that point to understand if they disengaged out of lack of interest or were just interrupted in their listening. Furthermore, we'd profile listening habits based on searches or organic browsing in conjunction with the length of time a user spent on a podcast to offer podcast recommendations based on community listening habits. This product has a wide range of potential applications, from increased accessibility standards compliance to wider audience outreach to enhancing support for podcasts as a key education tool for the neurodiverse community. Thanks so much for your time today, and the link to the demonstration portal is now on screen.